Hello everyone, I'm creating these videos for Project 2 and the course LIS3781, which is currently named in the spring of 2020 as the Advanced Database Administration course. And this is for Project 2. There are three sections for Project 2, three requirements for Project 2, and that is the completion of Chapter 16, the questions for that. The questions come from the textbook, Chapter 16, the required textbook. There are 20 questions. The second portion comes from this link here, Guru 99. Please make sure that you carefully read through the subheadings that are listed here in the requirements document. And then the questions from the subsequent questions, 21 through 45, can be answered by going through the documentation, these subheadings. I think you'll find it interesting working through those examples. But again, the questions that follow, 21 through 45, all come from these subheadings listed at this link. Next, after 45, is what the predominant resources that we're going to be using for the remainder of this video, and that is here are the deliverables and the exercises that we'll be providing solutions for. So the deliverables, at least one screenshot of the MongoDB shell commands, like for instance show collections, but you really should have more than that if you want to promote yourself to a prospective employer. And gang, you know I've said this many times in class, why are we here? And that's to be successful. So do 2 or 3 screenshots of MongoDB, maybe some optional JSON code, but my recommendation to you is that if you do the code, do a screenshot of it rather than uploading a file. And then of course make sure that all of these files are associated with your README file for LIS3781 for the Project 2 subdirectory. Here are some more resources here for how to do Mongo import, which you do not have to do for this particular project. You can, and if we get a chance to discuss it further in class, but everything I'm going to show you is all that you need to be successful to complete the third portion of the Project 2 requirements. And that is, we'll be going through the commands. So I have already imported this file, primer-dataset.json, which you do not, and if we get a chance in class we'll talk about it. But I've already imported it, and when I do that, or when I did that I should say, I imported the restaurants collection. And the restaurants collection, based upon this generic import, by the way this is a local import, not something that we would do with the Atlas remote server, but this is this is a local generic import that I have on my machine as well too, but I'm going to be doing everything remotely using the Atlas server, and that is the restaurants collection, which will be imported into the test database. Alright, here are the commands for the remainder of this assignment. So the first thing we're going to do is do show DBs, use test, and show collections. Then we're going to go through these exercises. Well, let's do that. So I'm connected here again to the MongoDB remote server. I have an account with MongoDB with the Atlas Mongo server, and it's a free account, and they provided me with a connection string, and I'm going to invoke some of these commands. But I'm doing this all remotely, so if we get an error, which I hope we do, then I'll show you how to get out of that error. So I already connected, you could see here, and I'm going to do show DBs. Okay. Now, the first thing is, notice that I'm displaying admin, company, local, and test. And the only reason that they're displayed is because I have at least one document and at least one collection in a database for these databases to show. If I invoke this command, use my DB, and I don't have a MyDB database, it will automatically, excuse me, I think it's my allergies. It'll automatically create a MyDB database for us. But notice when I up arrow to show DBs, it doesn't list MyDB. And that means that I don't have at least one document in one collection in the database. So when you do show DBs, it means that you have at least one document in a collection in your database. All right, so I got here admin, company, local, and test, and all we're worried about here for this particular assignment is the test database. Next command you need to do is to use that database, just like you would in MySQL. So use test, and then finally I'm going to do show collections. And you'll see that I only have one collection, restaurants. So we're starting now at this point where we're going to work with the remaining exercises here in completing Project 2. So a couple background notes here. MongoDB is the default for the Mongo. In MongoDB, the default database is test, and if you didn't create a database, then collections will be stored in the test database when you do an import statement. So it's good to explicitly indicate that you're going to import into the test database. But again, unless we talk about that in class, don't worry about importing the data, but just follow along with this video. So all these queries right here will come from the restaurants collection in the test DB. First off is display all the documents in the collection. All right. The solution for that is number 1 here. I'll make it just a little bit larger for you. And unfortunately, if I do that, then you're not going to see all the comments. Like for instance, the comment here on line 33. So I'm going to have to leave it like this, but you should be able to see that, especially when I highlight it like that. And notice that when I invoke this command, it's going to retrieve the first 20. Okay? So watch what I do. I'm going to invoke this command, and it's going to invoke the first 20. If I want to see more, you see here it says type IT for more, and IT is a shorthand in MongoDB for iterate. So I would iterate through the collection. So IT, okay? Now I could, unlike a SQL statement, I can actually invoke this command in MongoDB without the semicolon. So watch what happens, and still I get the same return. Then I could do IT, but I could do IT and keep going through the 20 documents at a time, but I want to find out how many documents I have. So I could go just append another function called count. And that's the beauty about MongoDB and the NoSQL document style data repository, database management system. You can just keep appending functions to it to get whatever you want to retrieve. So like, for instance, I could do a sort function on it. I could use the limit function on it. And watch what happens when I do count. It's actually 25,359 documents inside of the restaurants collection. But again, the answer is db.restaurants.find. And the convention here is to do the db keyword, db dot, regardless of what the database is. Once you use that database, for instance, use MyDB, it would be db.restaurants.find. If the restaurants collection was put into your MyDB database, doesn't matter. You're still going to use db dot, then the collection name, and then the function that you want to use on that. If you want to use more than one function, you just append a function using the dot syntax. So dot find, parenthesis, close parenthesis, dot count, just like I did here. All right? Okay, so here's the answer for number 1. Number 2. Let's do number 2. Number 2. Display the number of documents in the collection. Well, just did that, right? So number 2 we just actually did. And you can see number 2 right here. So here is the same command, db.restaurants.find.count, and it is 25,359. Okay, so that's the number. That's number 2. Number 3, I want to retrieve the first 5 documents. All right, well, how do we do that? Number 3, retrieve the first 5 documents. So like MySQL, but different syntax. In MySQL, it's not a function, it's actually a keyword that you would use limit with. But here in MongoDB, they try to use the same convention a little bit. So the developers, the designers of MongoDB noted that, you know, a lot of open source platforms like MySQL, which was the most common, they wanted to keep the same some of the similar commands so that it would be an easy transition from MySQL developers going to MongoDB. Notice retrieve 5 documents. I'm using the limit function, and the argument I'm using here is just 5. There it is, the first 5. Again, I do not have to use a semicolon, and I still get the same results. All right. Number 4, retrieve restaurants in the Brooklyn borough. Okay, number 4. So here it is. Notice the syntax here. I'm using the find function, which has an open and close parentheses, but then because it's a document, and here I'm doing a field value pair. The field is in double quotation marks, and then the value is Brooklyn. That's in parentheses. Curly brackets. The function is in parentheses. The field value pair is in curly brackets. So let's try to find that. Retrieve restaurants in the Brooklyn borough. All right, and I'm going to invoke that and hit Brooklyn, and there we go. Now I don't want to keep doing IT. I could, but I could just do count to see how many. And there are actually 6,086 restaurants in the Brooklyn borough. So I could show them, or I could do a count on them. All right, next, number 5, retrieve restaurants whose cuisine is American. Now you'll see that this is a tricky one. It doesn't have to be, but you'll see why. Number 5, here is the answer for number 5. Now if you notice, if you're seeing this, I put comments in there, there's an error. Let me show you why there's an error. Excuse me. Nothing. Well, I'm sure I have American cuisine in this restaurant's collection. And what I found was when I opened up the actual file that they put a space in there by accident. So if I put that space in there, I will get all of the American all of the restaurants in this particular collection that have American cuisine. If I do a count, you'll see that there's actually 6,183. Well, how did I find that out? Well, I just went through the data and I saw that they had American with a space. Well, what happens if I didn't know that? Here I could do this as well too. Now this is not required. The answer for number 5 is actually either one of these, okay? And I'll have the correct answer when you open up the project to submit it. But it's one of these two, okay? Either with the space or without the space. Now, this is just something additional for you. What if I didn't know if there was a space at the end? As a matter of fact, it could be 2 spaces or 3 spaces. What could I do? Well, I could use a regular expression. Now, those of you who had me in other classes know that we start a regular expression, not all the time depending upon the language, but generally we'll start a string. Regular expression for a string is / and the start of that string is a caret, and that would be shift 6 to give us that caret. The end of the string would be $/. Now what is this \s? That means to include all white space characters, including a new line, for instance, character, a tab, any number of spaces, but it will include all the white spaces. So I could run this as well and see that I would get the same return, right? And if I did a count to that, I would get the same value, 6,183. What about if I wanted to check American? I didn't know if it was spelled case sensitive or insensitive. Case insensitive. I would just put another regular expression, I. So after ending that string, $// I put I in there to indicate there would be a case insensitive search. So here's two things. It would include any white space values after American, and it would be a case insensitive search. So I just put that in there, and you'll see that it does the same thing. And notice what happened. It hung up my connection, and I'm glad it did. So what do I do when it hangs it up? I just type in Control-C. Control-C will unhang it up, but then I have to log in again. So log in again, and I'm glad that happened while I was demonstrating. And I can tell I typed the incorrect password by accident. Let me try that again. And there we go. So I'm in, and I can then do the case insensitive search. Let me do that right here. Let me copy this again, and I'm going to do the case insensitive search, even permitting any white space characters after American. Hit enter, up arrow, do .count, and it should be the same value, 6,183. Okay. Also, gang, if I wanted to, I could find out if there's any spaces in front of American by doing the \S over here like this. And it would also take care of any spaces before American. But again, the answer is one of these two. Okay, I'm going to end this video right now and continue on with the next video. See you in a bit. Moving on now to number 6. So retrieve restaurants whose borough is Manhattan and cuisine is hamburgers. Realize that we're using the Boolean logical operator here, and meaning that both conditions must be true. Borough is Manhattan, and the second operand is that cuisine is hamburgers. The operator would be and. So borough is Manhattan and cuisine is hamburgers. Remember your truth tables. Both conditions must be true, otherwise false for the and logical operator. Let's go to the solution. And there's actually two ways you could do this. We're going to talk about the first way here, and then we'll talk about the second way later on. So, excuse me, using the find function again, using the curly brackets for the field value pairs. Now notice there's two field value pairs here, and you can easily identify the distinction between the field and the value. So the field is actually on the left side of the colon, and the value is on the right side. The comma just separates the second or third or fourth or however many number of fields you have, field value pairs. So here's the second field value pair. Cuisine is the key or the field. Now we talk about that's the key there, just like a how you would identify something you're using a key value pair, just like an associative array is in key value pairs, right? The key is cuisine, and then the value would be hamburgers here. Okay, we want to see that both conditions are met. Restaurants whose borough is Manhattan and cuisine is hamburgers. Let's run that. And there we go. What do we want to, we could do IT to iterate more, or we could also find the count. So dot count. How many restaurants in the Manhattan borough whose cuisine is hamburgers? So let's hit enter, and you see there's 124. Okay, let's go to number 7. Display the number of restaurants whose borough is Manhattan cuisine is hamburgers. Already did that, right? And here's number 7. So number 6, that stands for number 6, and you could pause it. Number 7, I got some other things here if you want to do too, but the ones, if it doesn't say 5 or 6, if it's 6A, B, C, whatever, that's just extra additional information. You could take a look at the comments I have here, pause it and take a look and see what's going on. You'll see that I have a variable here. Let me make that a little bit smaller so that you could see the entire length of it. So here I'll be using a JavaScript variable. You could take a look at that. That would work if you had this data set. But again, not required. We're going to focus on the solutions to the assignment. Number 7, I already did number 7 for you. It was just to append the previous answer with count. And we already did that right here. Okay? So here it is again, count and 124. Right? There's 124, and you can see the command db.restaurants.find borough : Manhattan, comma, cuisine : hamburgers .count. The syntax is unusual at first to get a handle on, but once you get used to the syntax, it becomes pretty straightforward. Number 8, query zip code field in the embedded address document, retrieved restaurants in the 10075 zip code area. Let me talk about this, why it's embedded. Gang, what I'm going to do right now is I'm going to run the find one command. So watch this. I'm going to up arrow. I'm going to delete all of this. And I'm going to do find one. And you notice it gave me, it doesn't necessarily mean it's the first one, by the way. There's some additional information on what this actually returns. Generally it's the first, but it doesn't necessarily mean that it's the first. Usually it is, though. I don't want to get into specifics or in the weeds on this. Just realize there's a function called find one. It's case sensitive. The O is capitalized. Let's talk about this. I'm pulling up one document. You can see by the open curly brackets right here, okay, and you could see by the closed curly bracket right here. It's only one document, but inside that document, the beauty about NoSQL and a NoSQL solution, whether it's MongoDB or something else, is that it can be unstructured data. So not every document, unlike a relational table, has to have the same number of attributes. So here we see that each document, first of all, has a primary key. That primary key always starts with _ID. Okay, that's the key. And if you don't give it a value, when you import a data set, or if you even insert a document, it'll automatically provide that _ID, the primary key for that, with a alphanumeric value that MongoDB will provide automatically for you. It's almost like having an auto increment, only it's not an auto increment but an alphanumeric value. So this is the primary key _ID. Notice that address is actually another document. Why? It has curly brackets. There's an open curly bracket, here's a closed curly bracket. So what does that mean? Well, it means that address has multiple values in there, key value pairs. Now, it's an embedded document because address is a document inside of another document. Now notice that address has a scalar value when we say, or scalar component, and that is that building is a field or a key, and the building number, you can tell by the colon on the right hand side, is that value. So for this key building, it's 2206. Now coordinates is an array and has two values. So coordinate is a key, but it's an array. You can tell by the square brackets, and it has two values, two elements, if you will. And these are the coordinates for this particular building. Street is another scalar quantity. When I say scalar, you can look that up. It's SCALAR, scalar meaning one, meaning it has one key, colon, and one value associated with that. Zip code, notice zip code, street, coordinate, building are all inside the address document. You could tell by the curly brackets, and this address document is inside of another document. That's why I would call it an embedded document. Borough is not part of the address document, but it is a scalar quantity inside of this main document. So the question was, number 8, query the zip code field in the embedded address document, retrieve the restaurants in the 10075 zip code area. Well, I went through this whole explanation, and to show you some of the code here, notice that, let's go through it again. Here's the document that we pulled up with the find one function. ID is a scalar quantity. It's the primary key. Address is an embedded document. Borrow is a scalar quantity, one field or key and value. Cuisine is one scalar value. Field is or key is cuisine, and the value is Jewish kosher. But notice grades is an array. Why? We could tell by the square brackets. But guess what? Grades is an array of documents. Now, how do we know this? Because you could see the curly brackets here. There's an open curly bracket. Here's a closed curly bracket. So grades is an array inside of a document. I know it gets a little confusing, but after you get used to this, you can figure out, oh, that's an array, and cuisine is a key with a value inside of a document, but grades is an array inside of a document. And grades contains documents inside of the grades array. So here's the first element for the grades array. It's a document. The first element would be a document. Why? What does it contain? Well, it contains a scalar value of date and the date time with a grade and with a score. The next document is here. The next document is here. So, and also be careful because the last document doesn't have a comma. But grades is an array that has 4 documents. And each document has 3 field value pairs or key value pairs. Next is name, scalar quantity, key is name, kosher island, and finally restaurant is a key value. Notice that after this value there's no comma like there is in the ones above it. And then we finally end this document with a curly bracket. Alright, why did I go through all of that? Because address is an embedded document and street is inside of address. So how are we going to access this? We're going to access it like this. Here is number 8. This is how we would complete the requirement for number 8. db.restaurants.find, call the name of the document address because it's an embedded document address, and then inside of that document .zip code. And what's the value? Well, we can note the value by the colon. So on the right side of the colon is the value. So let's run this. Not in my buffer, sorry about that. Let me copy this again and run it and paste, and there it is. Let's find all of the restaurants in the zip code 10075. Let's do a count function on it, .count, and there's 99 inside of that zip code. Okay, so the answer for number 8 is right there. db.restaurants.find, the document, the embedded document is address, the key is zip code, and the value is 10075. Let's go to number 9. Number 9, retrieve the restaurants whose cuisine is chicken and zip code is 10024. Okay, let's go there. The answer is right here, but there's 2 answers for this question. We've done this before, remember? .find, key, value, comma. Well, we have an embedded document here, address, but it's still a key value, right? The key is address.zip code value, and we're using what's known as an implicit AND operation, like in the above, one of the above questions that we had. So let's run this and see this, and we'll see if we get the answer for that. There's only 2, so 2 restaurants met that AND criteria. And what was the criteria? That the cuisine is chicken, and that's the operand, and the zip code is 10024. There's another way we could do this. So we could do it like this. Both of these answers are required, and we could also do it using the AND logical operator. Now this is a little bit tricky, but still understandable if you follow along. Using the find function, parenthesis, Then, because we're using JSON, we're using the parenthesis here, finding the AND logical operator. If it's an operator or something specific to MongoDB, it's going to have a $sign in front of it. If it was an OR logical operator, which we'll see next, it'll have a $sign. So, and colon, and then we use our brackets to indicate, okay, what do we want to compare in here? Now, if we wanted more than one in that AND logical operator, we could just do comma, comma, and put those separate key value pairs. So, AND colon bracket, curly bracket, field value pair chicken, comma, address.zip code colon 10024, end double quotation mark, and then we have our parentheses here. But then after that, we could have put another comma if we wanted to, and we could have included some other criteria. So say score. We would say score colon 12 or whatever, grade, comma, grade colon A. We could keep appending these criteria using this AND logical operator like this. Okay? So let's run this, and you'll see that it actually works just the same way. And it'll return only 2. See, there's only 2 restaurants that meet both of those criteria. So this is the answer for number 9. And, no pun intended, this is the answer for number 9. Both of these are the required answers for number 9. Number 10 is pretty straightforward and simple. If we're using the AND logical operator, what about if we want to do the OR logical operator? Okay, so with the AND logical operator, both operands must be true, otherwise false. With the OR logical operator, both operands must be false, otherwise true. So with AND, it must be, the cuisine must be chicken and zip code. With the number 10, the chicken can be, must be chicken or zip code is 10024. So let's just do a count on that for the AND logical operator. And we see, again, we showed them, there's only 2 that meet that criteria. What happens if we use OR? I'm just going to up arrow here and change the AND to OR. You see there's a lot more. Let's do a count on it with the OR. So the cuisine is either chicken or in the zip code of 10024. You see there's 608. Okay, right here there's 608. So both criteria and 2, either criteria or 608. So the answer for number 10, gang, is similar to 9, but we're just using OR instead of AND. Alright, gang, that's it for 10. Now we're going to do another video. Alright, everyone, let's finish up here, or continue, I should say. Retrieve restaurants whose borough is Queens, cuisine is Jewish kosher, sort by descending order of zip code. Now, remember I said at the beginning of these videos that you're just appending functions to other functions. Let's take a look at 11. So here we're doing db-restaurants.find, same as before, the curly bracket for JSON. Notice that my text editor, Emacs, and if you have a good text editor, it'll do the same thing, automatically display the ending curly bracket. It does the same thing for any paired sequence of delimiters. Like, for instance, look at the open parenthesis. Does the same thing. Now, we already know how to do the implicit AND. So retrieve restaurants whose borough is Queens, cuisine is Jewish kosher, and essentially borough is Queens, and it's implicit there, right, in your requirements. And cuisine is Jewish kosher. Sort by descending order. Well, excuse me. Here we're using the key value pairs with the comma and cuisine colon Jewish kosher and curly bracket and parenthesis. Then just do the sort function, dot sort. So dot sort, again, using the JSON syntax, curly bracket, Remember, address is an embedded document. Zip code is in descending order. Now, what does that mean? Well, we just put a -1. So, +1 means ascending order, -1 means descending order. Let's take a look at this when I run this. Okay, and let's just see. So if you look at zip code, here's 1169, 691, 11435, 11435, 11418. You can see they're in descending order. Okay, we could even do a, we already did a count, but we could do a count again here in Queens and Jewish kosher using the count function, and you can see if I scroll to the right, then I'm in fact invoking that count function, or I should say appending the count function. And if I scroll to the left, you'll see how many. There's actually 62 Jewish kosher restaurants in the Queens borough. Just so you know, this is the requirement for 11, but just as an additional, you could also do it like this, using the AND logical operator, as we indicated before in number 9 and number 10. Using AND logical operator, and number 10 using OR. Here we're using AND again, number 11. Okay, either one of these statements would work. All right, let's go to 12. And 12 says, retrieve restaurants with a grade of A. All right, well that seems fairly straightforward. Or does it? Or does it? Well, let's go back to our find one function. Remember I told you that grades is actually an array? Let's take a look at that. I'm using the find one function, and I'm only doing this to show one document. But notice that grades is an array. And by the way, grades is an array of documents. As I mentioned before, there are 4 documents in here. Look at that. Each restaurant can have more than one grade because the dates are different. And by the way, because we're using unstructured data, each restaurant can have a different number of grades. So that's what's cool about that. We could do the same thing in a relational database management system as well too, but it would be a little bit more challenging to make the design fit the model. So here we have an array of documents, different dates, different grades, different scores. So, and don't ask me about the scores and the grades. I don't get it. How can someone get a grade of A and a score of 9 and a grade of A on a different date and a score of 12? I don't know, but let's just go with the data. So it's an array of documents, and what we have here is retrieve restaurants with a grade of A, and number 12, there it is right there. Okay, so find the restaurants with a grade of A, and go right here. It probably is not going to show because I have another command in my buffer. Let me try that again. Number 12, and there we go. These are all of the restaurants with a grade of A. If I do count, we'll see how many there are. Wow. Out of the 25,000 restaurants, at some point, a whole lot of restaurants got an A grade. So it's 23,440 out of 25,000 plus. Okay? So at some point in that array of grades, each restaurant ultimately got an A at some point. All right? That doesn't mean they always had an A, but it means at some point they had an A. All right, so the answer here is number 12 right there. All right? Number 13. Retrieve restaurants with a grade of A displaying only collection ID, restaurant name, and grade. What does that mean, the collection ID? Remember when we did our find one? The collection ID is this ID, the primary key. Underscore ID is how a document is uniquely identified, much the same as a primary key in our relational database management systems. So let's see the answer here. So number 13, we want to retrieve the restaurants with the grade of A, displaying only the collection ID, the restaurant name, and grade. Now let's break this down. Now here, gang, unlike sort, a positive 1 means sort ascending, as per number 11. Right? Sort function, negative 1 is descending. Okay? Here, we're saying that we only want to display the name key. 1 means true, 0 would mean false. And the grades. And grades is an array, so it would be grades dot the grade. And we want to show that. Now, notice that we didn't indicate that we wanted to show the collection ID here, but it will show anyway because it shows by default. If we want to turn it off, we'll take a look at number 14. But here's the answer for number 13. Retrieve the restaurants with a grade of A, displaying only collection ID, restaurant name, and grade. And here it is right here. Notice we're displaying the ID, as you can see. We're displaying the grade, all of the grades, by the way, and the name. All right, so if a restaurant got more than 1 grade, we're displaying all of those grades. Like for instance, here, a restaurant name is, which one I want to show? The name is May Kitchen. May Kitchen got a B, an A, C, a B, and a B. Notice that the beauty about the NoSQL document type of a database management system, each of these restaurants could have more than 1 grade, and it could easily pull in that data and easily report on that data. So again, here is the answer for number 13. Realize that the underscore ID primary key will automatically be displayed unless you explicitly state that you don't want it displayed, which is going to lead us to number 14. So number 13, again, underscore ID is displayed even if we didn't include it in our statement. Let's look at number 14. Number 14, retrieve the same thing as number 13, grade of A, displaying only restaurant name and grade, but don't display the underscore ID, the collection ID, the primary key. Don't display it. So what we have to do, look at number 13, then let's look at number 14. You'll see that we have to explicitly state we don't want to see underscore ID. So 0 means false. Watch what happens now. I'm going to run this. And it crashed on me again. It froze on me. So I do Control C like cat, Control C, closes out of it. I got to re-log in, password, and use test. I'm glad that happened again. And then we're going to run 14. So there it is. Let me up arrow on 14. Notice that there's the command right there. Okay, this is the command I'm running right here, and it's going to show the grade of A. Well, it's going to find the restaurants with a grade of A. It's going to show the name, the grade, and not show the ID. Okay, and take a look. So there are the grades, all of the grades for each restaurant, and the name, but we're not showing the ID. The ID would always be indicated first, like it was here in number 13. So you see in number 13, without explicitly turning it off, there's the ID, the primary key. Okay, that's number 14. Let's go. So the difference is number 13, here's the answer. Number 14, here's the answer. And then let's go to number 15. Number 15, retrieve restaurants with a grade A, sort by cuisine ascending and zip code descending. So in MySQL, we would call this a major minor sort. So the major sort is always the first one to the left. So sort by cuisine ascending. So all of your cuisines would be in ascending. Then after that, then we would sort the zip codes in descending. Let's take a look at the answer. So here's number 15. Let's take a look. This is the easy part, right? Grades dot grade of A, sort cuisine colon 1. Again, we're using the sort function, so 1 means ascending. Address embedded document dot zip code -1 is descending. Let's look at it, and let's look at the return as well. So I'm going to delete all this and invoke this command. There it is. So this is the command I invoked. We're going to take a look at the cuisine ascending and then the zip code descending. Let's look at the cuisine. So if I scroll over here and just eyeball the cuisine, you see that cuisine here is Afghan, cuisine Afghan, cuisine Afghan, cuisine Afghan. All of these are Afghan cuisines, but if I go back and look at the zip code, so you could tell Afghan is A, right? So all Afghan, and then here we got African, because the R comes after the G, it's in alphabetical order, so it's ascending, but look at the zip code, is descending. So for all the Afghans that are restaurants, the cuisine restaurants, we're showing the zip code descending, 11418, 11367, 11367, 11365. So we did our major and minor sort. The major sort, of course, is that we want the cuisine first and ascending, and then the zip code descending. All right, gang, I'll stop for now and come back shortly. Number 16, retrieve restaurants with a score higher than 80. Well, it looks a little bit odd at first, but if you can remember from the previous discussion, anything with a dollar sign is going to be an intrinsic I don't want to say function because it's not really a function, but an intrinsic operation. So if you want to do using the AND logical operator, we'd be do $and, or logical operator $or, and if we want to do greater than, it's already built in. We just do $GT. If we want to do greater than or equal to, it would just be $GTE. Okay, so the answer for 16 is here. Retrieve restaurants with a score of higher than 80. Let's run this. And there it is. Let's do a count on it. And let's scroll to the left. There are 12. There are 12 restaurants with a score higher than 80. Wow, that doesn't seem like a lot, does it? They must be really strict in their scoring. Evidently not in their grading. They have a lot of A's, but not a lot of scores higher than 80. Now, that's the answer for number 16. What if we did greater than or equal to? So let's do greater than or equal to. Let's just put an E here. And instead of displaying it, let's just show the count. And there's 13. Okay, so there's 12 that are greater than 80, and there's one that evidently has a grade of 80. The answer for 16, again, though, is still that answer without the count function. All right. Now comes the time to show CRUD functionality. What do we mean by CRUD functionality? Well, web application design, CRUD functionality means create, read, update, and delete. And the create really is the insert portion. So we're inserting data. Read would be comparable to using a select statement in SQL, or here we're using a find function in MongoDB. Update would be using an update statement in SQL, and in MongoDB an update function, and delete. So let's talk about first, we talked about retrieving data. Let's talk about inserting data. All right, so the question is, insert a record with the following data. So your boss wants that you're doing reports at your job, and your boss says, hey, can you insert this data into our MongoDB database for our restaurants collection? Sure, not a problem, we can do that. Notice what's not in here is a primary key _ID. So we're going to insert a record. We're not going to include the ID. However, you'll see that MongoDB automatically includes a primary key with the specific and special field name or index name. The correct terminology for MongoDB is really the key name. The key name is _ID. But your boss just wants the straight would be the key. Value is 7. Zip code is a key. Value is 10024. So in other words, your boss wants all this data in there. Okay. Well, how are we going to do that? A little bit differently than in MySQL or SQL Server or Oracle. First of all, let's go back to seeing an example. We're going to use the find one function again. And that's a really neat function, as I mentioned in previous videos, to take a snapshot of the data, how each document looks, one document looks, what's included in the document. Is it arrays? Is it scalar quantities? Are there embedded documents inside of a document? So let's do find one, and we see again from find one that we have an object ID. Again, that's a primary key, an address, which is it's an embedded document. We talked about that. ID is a scalar quantity. Borrow. Excuse me, I got something in my throat. I'm sorry. Borrow is a scalar quantity with a key of borrow. Value of Staten Island. Cuisine is a scalar quantity. Cuisine is a key. Jewish kosher is a value. And grades, as I mentioned before, is an array with 4 documents inside of that array. And inside of the array is inside of a single document. Name is a scalar quantity. Key is name. Kosher is island. And finally, restaurant is a scalar quantity of restaurant ID. Excuse me, is a scalar quantity with this value. Now, we looked at the data. We get a snapshot of it. Now we know how to insert it using this particular format. Now, we're not going to add an ID, but we can copy and paste all of this like this, copy all of it, and use that as a template to create our insert. Now, the only thing that's missing here is this. Your boss also wanted you to add in this insert, I should say your boss didn't ask you to insert an ID value, and you'll see that it will automatically add that ID value for you. Not this one, but a unique one. So let's go to the solution of number 17. We can copy that, and then we could use it as a template for doing our own insert. So here's the data again, and here's how we would insert it. Now, I showed this pretty function here. We already did that. I used to find one. You could also do this and see the same thing. And this is being more accurate than find one actually, because now I'm making sure that I'm getting the very first document inside of that collection. Using find one doesn't guarantee that. And I don't want to go into the specifics of it, but find one doesn't guarantee that it's actually in the collection in the way that it was entered. This one guarantees it. So find limit 1, meaning that we're going to limit it to 1, and use pretty function. Now, I said it wouldn't limit. It may or may not be. Sorry about that. I didn't put in my buffer. Let me copy that again and paste it. And you'll see that I got the same value as before, but it not necessarily will the find limit 1 equate to find 1. Usually it does, but sometimes, because find 1 acts a little bit differently than just find, you may not see the same record. Again, the only reason you want to do this is just to see what the format is. Notice if we didn't use the pretty function, well, watch what happens. I'm going to take off the pretty function here, and you'll see that it does it horizontally rather than vertically. Now that's fine and dandy. I get the same data, or I should say the same result set, but it's not in a really conducive format for finding out how I need to enter my insert statement, right? Using the pretty function or find one will at least show us how that data should be according to the JSON specification. So I see it, I can copy and paste this entire document and then modify the data to what your boss wants. So what you're going to get ultimately is this insert statement here. So here's my insert function that I'm using, and here it is. Let's insert that. And you'll see when I do that correctly, it'll say write result and inserted one. So I inserted one document. Now what I could do to verify it is just do step number 3. So step number 1 is to just find the first document in that collection and see what the format is. This is the actual answer right there. That's your answer for 17. However, if we want to verify it, remember, gang, like you've had me in other database courses, anytime you modify the data, you always want to do a select before and a select after. Here we didn't do a select before, but we are doing a select after to make sure that that insert is the last document in this particular collection. So we're doing a find, we're doing a sort, ID in descending, meaning that if we don't give it an ID, it's automatically going to give it the last one. So ID descending -1 and limit 1. We only want to see 1, and then let's see use the pretty function to see if it's actually this data right here. Okay, we're looking at this data, and we're looking at the data that your boss wants. This data right here. Let's see if it is. Okay, so here we're going to use this function just to verify it, and you can see it is. You can eyeball it. Now notice it automatically gave us an ID. We did not enter that ID in the answer. Here again is your answer. Okay, notice the ID, the primary key, is not entered. The MongoDB server will automatically do that for us if we have the other key value pairs in their appropriate order. So there it is, and there it is right here. This is the return. It added the ID. There's the street is 7th Avenue, zip code 10024. Scroll down, you see the date, and you see the restaurant ID. Let's just eyeball that and look at the data. There's the data we entered, right? It's exactly as what was entered into the system. All right. Okay, let's go to number 18. Let's change the first White Castle documents cuisine to steak and seafood. I don't know about you, but up north is where we have White Castles, and I've never seen White Castle with steak and seafood, so we're just doing this for fun. White Castle is somewhere you go to about 2 o'clock in the morning with your friends after you've been partying all night. So anyway, we're going to have some fun here. Usually White Castle serves burgers, really greasy, fries, etc. It's all greasy food stuff. But we're going to say steak and seafood and update the last modified field with the current date. Well, notice, first of all, well, let's go to the answer that I want to provide. So let's look at 18. Now, 18, I have this in steps. So the first thing is let's find the restaurants, the White Castle restaurants. Okay, and here's White Castle. We're assuming it's spelled correctly. These are all White Castle restaurants, and you can see by the return when I scroll over that the where's the name there? I'm missing it. I'm missing the name here. I got the zip code. Where is the name? There it is right there. Okay, names towards the end. White Castle, White Castle. These are all White Castle. All right? And the IDs are here too. Okay? Now, we want to get just the We want one White Castle restaurant, sort by name, in ascending. Okay, we could do that. So it would be the same like we just did above. But what we want to do really is get a snapshot of what this data looks like. Okay, so we're going to limit 1 like this, so we can update it. We're going to see what it looks like. So there it is. Okay, object ID 5E9CA. Okay, I got that. Address is building 531. Coordinates, etc., etc. Okay, what we want to do is we want to update this, the very first one. Okay, so the very first one is this right here. The very first one is this. We want to find out what the very first one is because that's the requirement there. Change the first White Castle restaurant documents cuisine to steak and seafood and update the last modified field with the current date. Well, it's not the answer, but we do want to get to the first one, so let's see what it looks like. And as I mentioned, here's the return on that. Notice also, well, first we need the object ID because we only want to modify this particular document. So I'm going to put that in a buffer, and then I'm going to paste it in here. Okay, I want to make sure, just like in SQL, that I am updating only that particular document. Remember how many sections do we have to, or how many components do we have to an update statement? We have 3, and that's update, set, and then where clause. And if you don't use a where clause, it's going to update all of the records in that table. Well, similarly to SQL, if we don't include the object ID, it's going to update all of the documents. So we don't want that. We only want the object ID with this particular ID. Now notice we're using the set value here, the intrinsic operation set. We're going to set the cuisine to steak and seafood, and the current date is going to be, well, notice current date has a $sign. Remember we said that anything with the $sign is something built in for MongoDB, and what that's going to do is return the current date, and it's actually going to return the current date in a timestamp format. I want to draw your attention to this. Notice as it exists, this particular document does not contain a last modified field or last modified key. So unlike in SQL, we would have to change the structure of our table to create a new attribute. Not so with NoSQL, that NoSQL solution, in other words for MongoDB. We could automatically use the update function to add additional keys. Notice again, there is no last modified key here, but we're going to add one like this. And the last modified key is here. True means yes, that it's going to be displayed. Here is our intrinsic operation, the current date, and here's the answer to number 18. I have a comment there. Be sure to get the correct ID, and we do have the correct ID. Let's copy that, paste it in here, and we see we had here matched 1 and modified 1. Okay, we matched 1 and modified 1, so it looks good. Now what we have to do, make sure that when you do that, that you actually go back up and check it. So let's go back up here and we'll do the pretty format. Oops, sorry about that, I got too much. let's go back up here and use the find, but see if it's been changed. And we're only going to see that first one. So db.restaurant find White Castle, limit 1, pretty. When we do that, we could see that the cuisine has been changed to steak and seafood. And we can compare that with the other ones by just doing this. So find name White Castle, enter, and we can see that these are all White Castles, right? And we could see that a lot of these are hamburgers, except for the first one is steak and seafood. Okay, so we correctly modified that. And again, gang, the answer for number 19 is just here. Oops, I don't want to go to that one. I want to go to this one right here. Make sure you get the right object ID. All right, that's the answer for number 19. All right, number 20. I'm sorry, that was the answer for number 18. Sorry about that. Number 18 is we changed the first White Castle restaurant to steak and seafood. So that's number 18. Let me go back here and show that again. Number 18, not number 19. Number 19. What we want to do in number 19 is delete the following records. We want to delete all White Castle restaurants. So again, we're modifying the data. Let's show delete here. And first we would do a find. Name is White Castle. Remember, if we're doing a modification of data, we want to do a select before, select after. We're going to show the name and the cuisine. We're not going to show the ID, and we're going to do a count on that. Well, it's actually not going to show the name and cuisine, but it's just going to do a count like this, and do that, and we see that we have 26. Now, if we wanted to see all 26, then we could just take the count function off. We would show the name key, the cuisine key, and not the ID, because 0 stands for false. Copy that, display it, and there it is. I could type IT for more. Remember, it returns the first 20, then the next 20, and you'll see that there are 6 more, right? Because it returned 26 with the count function. Notice that they're all White Castle here, all White Castles. Also that the cuisine for the first one has been changed to steak and seafood, not hamburgers. There's also another one here, sandwiches, but for the most part they're hamburgers. Lastly, delete all White Castle restaurants. All right? Well, we showed them. That's the answer for number 20. I'm sorry, number 19. I'm getting tired. Sorry about that. db.restaurants are removed. Name White Castle. That's the answer for number 19. Copy it. Paste it. And remove 26. Let's verify that. I'm going to up arrow to the count. And you can see that when I do that, there's 0. There are 0 White Castle restaurants now after I did remove. Okay? All right, gang, that's all of the questions for Project 2, the third portion of Project 2. Remember, Project 2 consists of 3 portions: the 20 questions for Chapter 16, 20 questions for Chapter 16, the questions 21 through 45 from the guru.com site. Remember to go through these subheadings. 21 through 45 comes from these subheadings. And then finally, the remaining 19 questions come from this particular set of videos right here. Okay? The ones I'm showing. All right, gang. See you all in class.